Now we're moving on to the ways in which stress can disrupt immune function, change it, um, inhibit it from doing its job. So let's go right to our notes and look at the variety of ways that the immune function actually can be disrupted. First, stress can actually decrease the formation of new lymphocytes and also decrease their release into the circulation, which means fewer lymphocytes, less release, double whammy. You can see so many times we've got double whammies, if you will. Stress can reduce the amount of time that pre-existing lymphocytes actually even stay in circulation, so they're not going to be out there doing their job for as long. Can decrease the production of antibodies, and also decrease the communication among the lymphocytes. Remember that this crosstalk among lymphocytes is very important for kind of mounting the right kind of attack and enough of an attack. This lack of communication actually means there's less release of relevant messengers to go on out there and do their job and do more communicating. And then many, many other ways. So I chose the four top ways that I felt would be particularly understandable and relevant for this course, but there's many other ways. Glucocorticoids, as you might by now suspect, are a major culprit in this entire process. Remember, they can shrink different organs because if the structure, the gland and brain area has receptors for glucocorticoids, excessive glucocorticoid release in circulation can actually start damaging the cells. So remember the thymus gland being a very important structure because that's where T cells learn, or thymocytes, before they become full-blown T cells, learn to recognize what is self and what they should not attack. And so the glucocorticoids can actually shrink the thymus gland, so the formation of new lymphocytes is halted. And this is really what is going on with most of the thymic tissue. So glucocorticoids can also inhibit the release of interleukins and interferons. Remember, they help lymphocytes be responsive to invaders. They're kind of like support and encouragers, while the lymphocytes now are less responsive to invaders, and there's fewer out there. Glucocorticoids also tend to return circulating lymphocytes to their storage sites. A little bit hard to understand or fathom, and we're going to talk very briefly about that in a couple of minutes. But glucocorticoids actually can kill lymphocytes, and they do that through a suicide protein that literally chops up the lymphocyte's DNA. Once you chop up DNA, that cell is a goner. So other sympathetic nervous system hormones, beta endorphins, and corticotropin factor, or I'm going to actually switch that to hormone, are also implicated. This is corticotropin releasing hormone from the hypothalamus. The precise mechanisms are still being investigated. There are many putative theories at this point, and the mechanisms are fairly complex. So what I want you to know for this is that these particular mechanisms do exist, and stress can influence them. The sympathetic nervous system hormones, beta endorphins, and CRH. But, and this is important, evidence exists that immunity is suppressed independently from glucocorticoid secretion. So glucocorticoids are not the complete answer. There's other things going on. Now, why would it make sense for immunity to actually be suppressed during stress? Longer term stress actually causes energy to be spent disassembling immune cells and tissues. So remember that, let's not spend extra energy on anything when we're running from the bear. And because of that, this does pose a problem for that concept. So there's something more to it. And this is also important. There's actually an enhancement of immunity during about the first 30 minutes of a stressor. Now, that's not very long. So if you are stressed out, let's say you're taking an exam, maybe that first 30 minutes, your immunity is actually enhanced. It's better. But that goes away. During that 30 minutes or so, more of some immune cells are released into circulation. Some cells become more responsive. And we see this happening after infections, like if one gets an infection. That makes sense, doesn't it? And after physiological and psychological stressors. Glucocorticoids actually, during this period of time, facilitate this response. So as you can see, nothing is easy. Initially, glucocorticoids stimulate the immune system and then return it to baseline. After a long duration of stress or excessive exposure to glucocorticoids for some other reason, maybe you're being administered exogenous glucocorticoids for some disease process, the immune system function actually plummets, and it plummets below baseline. So it's not just it goes back down, it goes down below the baseline. And that is referred to as immunosuppression. And why did it take so long to figure this out? Well, the techniques you need to use, the tools, the assessment devices had to be pretty sophisticated before we could actually note that this phenomenon, this temporary enhancement, and then a subsequent suppression. Sometimes what seems to be immunosuppression is actually an indirect way of enhancing immunity. For example, a subtle rise in glucocorticoids for a short time kills off only the older lymphocytes that don't work well. And this is actually a means of sculpting the immune response. And this is a concept that applies in so many ways to different areas. For example, you know, I'm sure most of you have heard, if you start taking an antibiotic, unless you're having allergic reactions or some other, you know, response that you absolutely cannot tolerate, you should take them until they're all used up. You don't stop taking them when you think you're feeling better, that you're feeling better, you don't need the rest, because of this same principle. The bacteria that you've killed out are the weaker ones, the weaker. And so they are destroyed first. What is left? Those strong bacteria who have the ability to do a lot of damage. And if you stop taking antibiotics before those are killed off, you're going to have a flare, and over time, that antibiotic may not be even effective anymore. So lymphocytes that are taken out of circulation, here at 2, are rushed to a specific site of infection, not deactivated. So, okay, we say lymphocytes are taken out of circulation. But for a short time specifically, this sounds bad, but what is happening is they're being rushed out of circulation because it's like a little ambulance going to the site of the injury. And there they can be like dedicated. So these are the things that happen, and this is expensive, it's costly. You're exerting energy for your immune system to actually be enhanced during this time. So it would just take too much. It would cost your body too much to stay in this mode for a long time. Secondly, chronically activated immune systems become even more active autoimmune systems, disease. So, and it's true, like active, overactive autoimmune diseases means that you just have this system that just goes crazy and it doesn't stop, and it just starts targeting tissues that shouldn't be targeted. There's something that Sapolsky referred to as the paradox of immune diseases. And this paradox basically is that if you administer large amounts of glucocorticoids or steroids, that is actually, in the case of an autoimmune disease, to make it less damaging. So, in other words, if you have an autoimmune disease, give steroids, you're suppressing your immune system. It can't attack your pancreas, your nervous system, or other organs, okay? But here's the paradox. Stress can worsen autoimmune diseases. So what the heck does this even mean? Remember that there are phases of responses. Go back to the appetite, that you have the CRH coming quickly and then kind of disappearing. And during that time, you don't have appetite, your appetite is suppressed, but then glucocorticoids are secondarily released, takes longer, but they hang around longer, and that promotes appetite. So it depends on how you have these phases occurring. So if you have repetition of the early increasing phases of the response, those that we talked about, those first 30 minutes or a little longer, that is probably where the stress actually can function to worsen the autoimmune disease that is already present. So, how damaging is stress-induced immunosuppression when it actually occurs? Evidence suggests that stress may indeed impair our immune systems and increase the risk, that's important, risk of disease. But it still remains unclear as to how much chronic stress makes you more vulnerable to diseases that would normally be fought off by the immune system. And this is a difficult thing to test experimentally. The link between something that increases or decreases stress and some disease or mortality outcome is presumed to be established through the following steps. And these are what Sapolsky presented. Okay, differences in pattern and frequency of stressors makes a difference. These variations determine how big the response is and how often the responses will occur. The stress response will be turned on. So if it's a lot frequent stressors pattern before one is completely resolved, another one hits, then bigger and more frequent stress response activation. And then the next step, according to this, paradigm, is that the magnitude and frequency of the stress response regulates immune competence. And then fourth, our level of immune competence affects our resistance to disease. So there are a lot of difficulties going from these steps. without having little glitches in between. This was one edition of Sapolsky's book, and some of you have a different one, so I'm just going to take the page numbers out, and you will be very able to see very quickly where this section is in the immune chapter. And then Sapolsky can talk a little bit to you about those steps and the issues. But here is the important part. This is what I really want you to know in terms of how these steps are assumed to occur. Now, areas where links between stress and diseases associated with immune dysfunction are suspected. We're going to have a chapter later on about social isolation and things like that. This is well generalized. This is among different species, different people, and it is really a strong association. The fewer the social relationships, the shorter the life expectancy, and the worse the impact of various infectious diseases. Now, I want to take a minute and add my own 2 cents here, because you can have a lot of social relationships, and some of them are just great social relationships, supportive, enjoyable. Others are toxic. I'm pretty sure some of us have relationships, social relationships, that by the time you get away from this person, you're like, oh, and that does not seem to be the purpose of having social interaction. So just a comment about that. People who score high on the loneliness scale have relatively depressed immune function, if you take a look at it. And social stressors tend to have a greater effect on the immune system than non-interpersonal stressors. Now this, when I first saw some of this literature, it really blew me away a bit. I'm like, wow, that means we truly are social animals, social beings, and this can totally affect our immune system, even more than non-interpersonal stressors. But don't forget about the other things that could be different in the lives of people with less social support that could play a role in this relationship between low social support and fewer social relationships, and the link with increased disease and mortality. Because we're going to be talking much more about that specifically in the upcoming chapter, that's all I'm going to say for now, but we will be addressing this later. Bereavement is another thing that appears to play a role, but generally there needs to be an additional physiological or psychological risk factor present for bereavement to actually increase the risk of mortality. Now, the one case this may not be 100% true is when you look at those people who lost somebody close to them that we talked about during the cardiovascular system. The common cold is another thing that has been implicated. People rated how stressed they felt. Then they were exposed to a rhinovirus, deliberately. Here, take a cotton swab, stick it up your nose. Hopefully it isn't quite as much doing that as when you get a COVID test that way. But it's not that it's horrible, it's just unpleasant. You'd rather not have that cotton swab stuck up in your sinuses, it seems like, for a long time every day. Anyway, those who reported more stress actually were more likely to develop a cold in response to exposure to the rhinovirus. And we saw the same findings in other primates in much of the literature. Now, obviously, the primates, gorillas, orangutans, chimpanzees, whatever, that you're looking at, don't fill out a self-report form about how stressed they feel. But there are behavioral markers, and there are also markers, other markers that you could utilize to infer the feeling of stress. So clearly there is some kind of relationship there. And let me just say as an aside that at the end of each semester during finals times, so many desks when we're face to face have a box of Kleenex on them. It's like people have colds, or you hear people sneezing and coughing and all this kind of thing. So I think it's kind of, we can see that in our own lives pretty readily. So what about cancer? What is the relationship of stress, especially prolonged stress, on cancer? Well, let's take a look at some rat studies. First, if you give a rat controllable stress, there doesn't seem to be any effect on incidence of cancer when exposed to a virus that has been associated with cancer. Epstein-Barr is one of them that it sometimes has been suspected as having a relationship. Now, how does this rat have controllable stress? You turn this blinding light on, terrible and loud noise. Rats do not like that. They do not like that. But this rat has learned that if he runs over and pushes his lever, that it'll turn everything off. So that ability to control the stressor makes a huge difference. However, if nothing this little guy does makes any difference, he cannot turn the lights up, the noise is still going, or a shock is still, occurring under his feet, then there's a higher incidence of cancers caused by a virus. The implications for humans are a little more challenging to acknowledge because most human cancers are caused by genetic and environmental factors. And even though I think it is reasonable to suspect a link, there has not been sufficient data to support that at this point in time. So, and one of the problems with the human studies in relationship to stress, development of cancer, is these human studies are retrospective in nature for the simple fact that we can't take a human and apply all this stress and then wait to see if they get cancer and watch that. We're going back. We're saying, oh, this was your stress that you reported, this is what you experienced. So, and in the very rare prospective studies, the ones where you try to take a person and then follow them through and see what the outcome is, you can't legitimately, assign them this horrendous, stressful life. You just have to keep track of what's going on in their report of it. There's not great evidence for the stress cancer onset link. Now, one important difference is that this is talking about the onset of cancer, not necessarily the progression of cancer. There is more evidence that if you already have cancer, that stress can actually exacerbate the symptoms and the progression of the cancer. So that's a whole nother kind of line of research actually that's being built as we move through medical history right now that's happening. It has been found that optimism, assertiveness, and social support may extend the life of those who already have cancer. Maybe it's because they have better self-care. Maybe they are more compliant with the medical professionals treatment plans. And so there are so many other factors that could be playing a primary role that it's going to take a lot of time to pull this apart, piece it apart. So finally, we are to the very last portion of this part of the lecture. And this is straight from Sapolsky. He puts it in as postscript, a grotesque piece of medical history. And it is. We've all heard of sudden infant death syndrome, SIDS. And some of you may have been aware of the fact that for a while it was like, oh, you should turn them on their back because if they're on their stomach, they're suffocating. So then they turned them on their back, and then all of a sudden they still were experiencing too many cases of SIDS, any cases too much. And this has been something that's been around for a long time. The acknowledgement that an apparently very healthy baby goes to sleep and then dies without any indication that there's a problem. It's devastating. Oh boy, and I should have fixed this a little bit. So in the 1800s, it was found that SIDS infants had larger thymus glands than the quote normal unquote dead infants. Now right there, that should make you go, what are you talking about? Because you're like, normal dead infants. Well, let's move on. And because you're going to see why this was such a huge mistake. This larger thymus gland was considered status thymico-lymphaticus. And you don't have to say that 5 times or anything. But so that was, they figured, okay, these larger thymus glands were so big that they actually suppressed the breathing and the baby died. Well, so these well-meaning, I'm sure, doctors recommended irradiation of the thymus to shrink it. So, okay, and trust me, in the 1800s, irradiation was not nearly as controlled and refined as radiology techniques that we have today. So they started, just healthy babies, irradiating their thymus, shrinking their thymus. Oh, we're preventing SIDS. But then it was noted that there was a huge increase in thyroid cancer in infants and children. And those thyroid cancers were the direct result of the irradiation that was given to them, supposedly to prevent SIDS. So let's go back for a minute to the normal, quote unquote, children. Well, what were the reasons these babies were dead? Most of them, it was either something like chronic malnutrition. Guess what? That's not normal. Chronic diarrhea, that was very common in the 1800s, and definitely takes its toll on any infant, child, or adult over time, or prolonged stressful diseases. Their thymuses had shrunk. It wasn't that the other infants' thymuses were too large. It was the children who had died who were normal really weren't. Their thymuses were smaller than they should have been. And that should take you right back to the idea of what happens to the thymus gland that we just talked about a few minutes ago, about it shrinking. And it is the site where our thymocytes are supposed to learn to be good T cells and take care of us that way. So it's really crazy sometimes when you think about some of these techniques that were used to try to correct illnesses, and then the other illnesses that were developing as a result of the treatment. I have another couple of pages of information for you regarding antibodies, antigens, major histocompatibility molecules, which are those that define self. And I'm going to post that for you. I may not get to talking through it right away, but we can always come back to it, especially during the review session that we'll have later on in the semester. And before that, if I need to address anything, that's fine too. I will try to get to it and explain some of it, but I wanted to get this much up for you now. So after you get that, the immune system work is done. And as I said, it was the biggest chunk you're going to have